Okay, here we are back at the VCAA 2021 Maths Methods exam number 2, multiple choice, the last group of questions here. Question 16, the first one. So cos x is 3/5 and sine squared of y is 25 on 169. And so x is between 3 pi on 2 and 2 pi, so that's our fourth quad, and y also is in our fourth quad. Okay, all right, so what are we looking at then? We're looking at the value of sine x plus cos y, so we need to know what sine x and cos y are. So based on what we've got, we're going to be looking at sine squared x plus cos squared x equals 1. And so let's have a look at the x, so sine squared x plus 3/5 squared is equal to 1. And so sine squared x plus 9/25 is of course 25/25. I'm just doing that because we've then got to take 9/25 from both sides, so sine squared x would be 16/25. And so sine x could be plus or minus 4/5 in that case. Now we're in the fourth quad, and in the fourth quad sine is negative, so we're looking at sine equals negative 4/5. All right, similarly for the y, sine squared of y, we've already got what sine squared of y is, so we don't need to square it because it's already been squared for us. So 25 on 169 plus cos squared of y, and that equals 1. And of course 1 of course is 169 on 169. So take 25 away, and so you get cos squared of y is 144 on 169, and so cos of y would be plus or minus 12 on 13. Now of course it's in the fourth quadrant where cos is positive, so the cos of y is 12 on 13. Whoops, 12 on 13, 12 on 13. And what are we after? Sine plus cos, so we're after negative 4/5 plus 12/13, and you do that on your calculator and you get 8/65. A. All right. Question 17. Question 17 says discrete random variable has binomial distribution. All right, so it's binomial. Probability of success is 0.1 for n trials where there's more than 2 trials. Probability of obtaining at least 2 successes, so the probability that x is greater than or equal to 2, at least 2, is at least, so it's greater than or equal to 0.5. So at least 2. Now we don't know where the top end is, we don't know where n is, where it finishes. So what we can do in this case, what we do know is where the bottom end is. We know x could be 0, and that can't be any less than that. So the probability x greater than or equal to is everything minus the probability where x is less than 2. And we want that to be greater than or equal to 0.5. And so that is, and if we then rearrange some of this stuff here, then what you find out by, adding 1 to both sides and dividing by -1, you find that the probability that x is less than 2 has to be less than or equal to 0.5. Now, probability x is less than 2 is the probability x is equal to 0 plus probability that x is equal to 1, and we want that to be less than or equal to 0.5. Now, we can't just go ahead and use the distribution thing because we don't know how many trials there is. But what we do know is we do know how to work out those probabilities. All right, because we can use the definition. You know, the NCR, probability success to the, I'm waffling. All right, so your binomial probability. All right, so probability x is 0. There's only one way of obtaining none, and that's 0.1, which is the success to the 0, times 0.9 to the n, plus there's n time ways of picking 1, and it's 0.1 to the 1 times 0.9 to the n minus 1. And we want that to be less than or equal to 0.5. So now we get our calculator out and solve that equation. And when you do that and solve that equation, you get that n is 16.44. If you just put solving this equation, make it equals 2 rather than the less than bit for the moment. So then it talks about at least. So for it to be at least, what do we need to do? Because you can't have fractions of a trial, you have to have whole. So we want at least, so we need to go n equals 17. We need to go up. All right. Then the next question number 18. All right. This is an interesting question. So we've got a function f and a function g, and the maximum number of solutions for the equation f of x minus k equals g of x. Okay, so this bit here, the fx minus k, is effectively is that, and we've got a translation. All right, in the x direction. So in other words, left or right. So what we can do with this particular one is we can use our calculator and we can graph, and we can just have a look and see. So if we bring up our calculator, and I prepared this one earlier, so there's f in the blue and there's g in the red. So then I'm going to graph them. No, sorry, I've done the wrong thing here. They didn't highlight the right thing. Come on, up here. There we are. Graph it for me. There we go. So there's F and there's G. Now let me zoom in. There they are. So remember the blue one's F, and we wanted the maximum numbers of solutions where f of x minus k is equal to g of x. So where the two are equal, they're points of intersection. So we're looking for the maximum number of intersections. Well, at the moment there's one, but if I took this blue one and I shifted it down to the left here, I could shift it far enough so that there would be 1, 2, 3 intersections. All right, so shift it to the left, say shift it to left 2, for example, then that's going to bring this point down there somewhere, and so it's going to be up here like, up here like so. All right, so actually we don't need it that far down. What we want to do is I want to bring it, this turning point, into here. So if I do that, and it comes up, 1, 2, 3. All right, so the maximum number that you can get is if you move it to the left, not too far to the left, because if you move it too far to the left, you move this turning point down here, and then it only just intersects the once. So you need that turning point to be in here somewhere. So a shift of 1 would do the job. Anyway, I'm waffling because that's not what it's all about. it's all about what is the possible maximum number of times that we can get these two graphs to intersect, and the possible maximum number of times is 3 if we just shift that to the left. All right, so the maximum number of times is 3. All right, so we can just use our calculator and then have a look to get some sort of visual to help us out. All right, number 19 is another one where we can use our calculator, and I'm not going to do that because it takes too long. But which one of the following functions is differentiable? So if it is differentiable, two things have got to be happen. It's got to be continuous at x equals 0, and it's got to join smoothly. So in other words, same gradient. Or really approaching, to be technical, but x equals 0. So you can use your calculator to help you with that, and when you look at these things, you find that these ones don't join smoothly. This one doesn't join smoothly. This one here, it's not continuous. And so, because at x equals 0, that's equal to 4, that one's equal to 4, and this one's equal to 1, so that doesn't join smoothly. And then we've got these other two options that we would need to look at as well. And when you have done that, you find that that particular one, option E, will satisfy these two conditions. All right, as I said, it take too long for me to show you all of that. All right, and the last question. A and P, two independent events from sample space. Probability of A is P, the probability of B is P squared. And when you add them together, they're 1. And we want to know what A complement union B is equal to. All right, so the probability of A is equal to P. So that means that the probability of A dashed would be 1 minus P. All right. So they are independent, two independent events. So if independent events are independent, then that means the probability of A intersection B is probability of A times the probability of B, which is P times P squared, which is P cubed. All right. And if we're looking at the probability of A dashed intersection with B, then because they're independent, that would be the probability of A dashed times the probability of B, probability of B, which of course is 1 minus P times P squared, which is then P squared minus P cubed. Now, why have I done that? Well, why I've done that is if I have a little thing here, there's A and there's B. So what we are interested in is the probability of A dash union with B. So let's have a look. So A dashed is everything outside the the circle. And then union with B, so everything inside circle B. So we've got everything out here, outside of A, and everything in B. So what is that when we look at it? Well, it's the probability of A dashed plus the probability of B. But by doing that, A dashed is everything out here, probability B is everything out, and then I've counted this part here twice. So I need to take away the intersection of A dashed and B. So here we've got then 1 minus P plus the probability of B, which was P squared, minus P squared minus P cubed. And then when you sort all of that out, what you get is, because this one and this one cancel, is you get 1 minus P cubed, and that is option D. All right, so back to the old Venn diagram stuff to give you a bit of a hand with that stuff there. All right, so that's it for section A. Other videos for the other multiple choice questions and more videos for section B.